Alright, today we're going to be taking our first look at angles. So to get there, we've got a lot of vocabulary, so there's not much computation in this section right here. We're going to be using angles for the entire year, so this is something that you really need to get down. We need to know how to spot them, we need to know how to name them, and we need to know what they are. So to get started, let's talk about angles. So what is an angle? An angle is formed by two rays with a common endpoint. So remember that a ray has an endpoint and then it goes on forever. So like ray BA or ray BC here. The common endpoint of this angle is called the vertex of the angle. And the rays are called the sides of the angle. So any angle has two sides and a vertex. So we can name a letter or name an angle using three letters. The important thing though is that the middle letter must be the vertex, has to be. So over here we could call this angle ABC, or we could call it angle CBA. They both mean the same thing. But what we can't call it is BAC or ACB. That B has to be the middle angle, or the middle point, the vertex. We can use a single letter if there's only one angle at a vertex. So like right here, we've got an angle kind of floating out in space, so we could just call that angle B. But if you've got multiple angles together, which we'll see in a little bit, then you have to use the three letters, because otherwise you could have multiple angles that you're talking about, and if in doubt, just use three letters. Using three letters is never wrong, but using a single one could be if there's more than one angle going on at the same vertex. Alright, so here's some stuff that you've seen before. We've got four different types of angles. Our first angle is acute, and an acute angle has a degree measure less than 90 degrees. So our measure here, M, is less than 90, and I don't know if I've used the degree symbol yet. So here's a nice Cami thought here. Anytime you want a symbol, just you can search for it, and you just type the first few letters and it'll show up. So we want 90 degrees. So the measure is less than that. Our next type of angle, this bigger one, is an obtuse angle. And in an obtuse angle, we have a measure greater than 90 degrees. Okay, our next one here, if you see this box here at the vertex, that means that you are looking at a right angle. Right angles are very important. We use them a lot. They're one of the few angles that we can just look at and know everything that there is to know about it. And a measure of a right angle is always exactly 90 degrees. And then finally, this last one doesn't look like an angle at all, but technically it is. So this is what's known as a straight angle. And a straight angle is basically two right angles together. So it is always going to be 180 degrees. 180 degrees. So straight angles become very important when we start trying to figure out like missing angles and that sort of thing, because anytime we see a straight line, we know that the angle is 180 degrees. Alright, let's look at some examples here. So on example 1, we've got this angle here with J and K and L. We want to name the vertex. So the vertex is the common one. So I'm going to use a capital K because a vertex is still a point, so we need to use a capital letter. We need to name the sides of the angle, and the sides are rays, and the rays both have an endpoint of K. So we've got KJ, and we've also got KL. And because they are rays, I'm going to use the drawing tool here And let's make this thinner. And show, whoa, that was awful. And show, that was not great either, but it'll do. Show that we have a ray. So a one-sided arrow, that's the meaning for ray. All right, we need 3 ways to name this angle. Okay, I have not used an angle symbol yet, so let me pull that out. This is your symbol for angle right here. All right, 3 ways to name this angle. First way, with 3 points, we can say that this is angle JKL. So we're going from J to K to L, with K being the vertex. A second way we could name this is just the opposite. We could say that this is angle LKJ. K is still in the middle. Now the next one, because there's no other angles here, we could also just call this angle K. Since there's only one angle at that K vertex, we are allowed to use a single letter here. And then we need to look at what type of angle we have. You can't tell exact measurements, but you can usually assume that something is either obtuse or acute, as long as it doesn't look too close. A right angle would be up and down right here, so this is pretty obviously an obtuse angle. It is much bigger than 90 degrees. Okay, I'm going to have you do number 2. And now we are going to move on to congruent angles. So in congruent angles, if the measure, so we use a small m for that, the measure of angle A is equal to the measure of angle B, then the angles are said to be congruent. So same measurements means that we have the same angle, they are congruent. This is written as, we're going to get out our congruent sign again. So angle A is congruent, so that's our equal sign with the squiggly on top, to angle, whoops, that's not an angle, to angle, come on, oh no, I broke it, angle B. So this congruent sign here is something that you're going to be seeing more and more as we go on, so get used to it. I'll say it again, I said it with segments, but anytime we're talking equals, then we're talking numbers. So equals means that these angles both have a 75 degree measure, so we can say that they are equal. The measures are equal. If we're talking about the actual objects, then we need to use congruent. So I can say that angle A is congruent to angle B, because angle A and angle B are both things, and we are no longer talking about numbers anymore. We're just talking about things. All right, moving along. So an angle bisector. So over here we've got angle ABC, if we look at the big one, and BD is bisecting it. That means it's cutting it exactly in half. So bi means 2, and then sector means basically to portion it out. So we're portioning it out into 2 equal sectors, so we're cutting it exactly in half. So an angle bisector is a ray that divides an angle into 2 congruent angles. So we're turning one angle into 2 angles that are exactly the same. So in the diagram to the right, we've got BD is an angle bisector, and that is a ray, so I'm going to put a ray symbol above it. So BD is an angle bisector, therefore these 2 smaller angles are congruent. So that's angle ABD and angle CBD. Those are congruent to each other. We cannot call them angle B because we've got multiple angle B's. We actually have 3 different angle B's right now, so we have to use the 3 points. So we can say that angle ABD is congruent to angle CBD. So B is the vertex, so it's the middle letter in both of these. All right, we can have perpendicular lines. You've probably seen this before somewhere along the way. So perpendicular lines are two lines that intersect. That means that they cross, essentially. They're not parallel at a right angle. So the symbol for perpendicular is hopefully in here. It should be. So if I type perp, the symbol for perpendicular is this guy right here. Just looks like two segments meeting at a right angle. And in the diagram to the right, we've got line L is perpendicular to line M. So I can say, let's see, I'm going to use my drawing tools to get cursive. So L is perpendicular to M. All right. We can also have a perpendicular bisector. So there's that bisector word again. So that means that we not only have a right angle, but we are cutting a segment in half. So the actual definition here would be a line, segment, or ray that is perpendicular, meaning it meets at a right angle, to a segment at its midpoint. So these hash marks here mean that this segment P to this point should be named also, but it's not. So this segment on the left is congruent to this segment on the right. That's what these hash marks right here mean. That means that that point that's not named, that should be, is the midpoint of segment PQ. So in the diagram to the right, we've got line LM is the perpendicular bisector to segment PQ. Segment PQ. And just as a final thought, a little bit of theory here. You cannot have a perpendicular bisector to a line or a ray. It has to be a segment, because if you have a line or a ray, you have infinite length, and you can't cut infinity in half. Half of infinity is just still infinity. So if we're talking bisecting segments, so bisecting anything that's like a line, it has to be a segment. It can't go on to infinity. So P and Q are endpoints. It doesn't go on forever. All right, let's try example 3 here, and then I'm going to have you do example 4, and then we'll be done with this video. So we want to write another name for angle CBF. So the first thing we're going to do is get out of that. So angle CBF can also be written backwards as FBC, as long as B is still the vertex. So we can call this angle FBC. All right, part B, we want to name the sides of EBD. So we've got angle EBD. So we've got two different rays that are the sides, and they both have an endpoint of B. So we've got BD and we've got BE. So BD and BE. And I'm going to put some ray symbols over there. Okay, we want to classify now angle ABC. Well, that's a straight line, and anytime you have a straight line, you've got a straight angle. So our answer here is just straight. Give an example of an obtuse angle. There's a whole lot that we can pick here. Just look for anything that's bigger than 90 degrees. I'll just start at point A here. If we go A, B, F, that would be an example of an obtuse angle. If If we go EBD, that would be an example of an obtuse angle. CBE would also be another one. So anything that's bigger than 90 degrees. So let's say we've got angle ABF. Name two congruent angles. Alright, so there's a couple options we've got here. The first one is that right angles are always congruent. So we could find two right angles and that would be right. The other thing is we've got these arc symbols here. And that is how we show that we have congruent angles. So let's name those angles. So the first one we've got is EBA. And we can say that that is congruent to angle CBF. Those are actually also what's known as vertical angles, which we'll hit in a couple days. And then finally, name a perpendicular bisector. So we need to find a couple segments that are congruent. So looks like we've got segment AC here, and then we've got AB is congruent to BC because we've got these hash marks right here. So since AB is congruent to BC, then that means that B is the midpoint, and this ray moving along here must be the perpendicular bisector. So we can say ray BD. And yes, these go on forever. Like point A, it goes on forever. Point C, it goes on forever. But if we're talking about the bisector, we are talking about just the end points. So I don't care what happens above A, and I don't care what happens below C. If we're talking a perpendicular bisector, I'm just looking at this area just from A to C. All right, that's all I've got. So I'm going to have you run through example 4 here and then bring your questions to class tomorrow.